Hey friends, it's Carl here with Calm Survival, and today we're going to talk a little bit about one of the elements of that rule of threes. We're going to talk about air. Now, in general, as I said in the intro, 3 minutes without air it's a bit of a stretch. Um, but air is obviously very important to us, and depending on where and when you are, then having good air is kind of important. Now, there's a lot of information out there on masks, and I encourage you to do some more reading, but I want to give just a really broad overview so that you know where you're starting and where you're looking from. Okay, so in general, we have to start with what our threat model is. So that could be wildfire smoke, house fire smoke, a biological threat, kind of like we're facing now. And then we have to figure out what we're able to protect against and what we're not able to protect against. Okay, so our threats are going to come into three categories. And the first category is going to be physical particles. So smoke, dust, and mostly droplets. So we can quickly see if we've got a fire, we're going to have smoke. In this biological sense, most of the time we're going to be dealing with droplets. Anything that's fully, truly airborne, that's going to be something different. We're going to have to make a different plan around that. But for the most part, what you want to do is compare the size of the particle that you're going to need to filter out and find the filter that matches that. Okay, so there's a lot of different rating systems. You just have to look them up. But that's going to give you, like, do you need an N95? Do you need a P2.5? You're going to find out what you actually need. Now, these are pretty easy. You can just block these. The next thing we're going to have is vapors. So again, with a fire, you're going to have, like if it's a house fire, there's the paint and the plastic and things like that. Those vapors are going to be pretty dangerous. Now, we can't block them, but we can absorb them into the filter, okay? So you might see something called VOCs, volatile organic compounds. That's pretty much the stuff in paint that, as it evaporates away, the paint hardens. Chemicals similar to that. So these need something to absorb them. These need something to block them, depending on what you're looking at. So in our current biological threat model, this stuff, not important. It's not going to do anything. A carbon filter is not going to do anything to block the particles. Okay? Usually activated charcoal carbon is usually what's used. You get into some much more specific threats, you're going to find that there are cartridges made to react with certain chemicals. You're going to need to do a lot of study and probably get some training by the time you get to that level. It's not something the average person runs into. And lastly, we have gases. Okay, carbon monoxide, carbon dioxide, nitrogen, maybe some hydrogen sulfide. Again, these are less likely, well, except maybe these first two. Somebody's going to go, well, nitrogen, it's most of air, but it can displace all the oxygen. These are still going to rely on there being enough oxygen in the air for you to survive. When we start getting into threats like this is where we get into there can be enough oxygen, but they are going to displace that oxygen. that's where we get into full air supply respirators. Now, if you don't have training, if you've never used one, they're not easy. It takes physical effort to breathe in a self-contained breathing unit. If you want a bit of an idea, imagine trying to breathe with your mouth fully open, head out the window, car driving 100 kilometers an hour. It's probably what it feels like. So these, we just have to avoid them. We have to make sure that we don't contaminate our environment with carbon monoxide with a bad stove. We need to make sure that we can actually exhale properly with our mask so that we don't get CO2 building up in our mask. It's definitely a risk. And we've got to make sure that these other hazardous environments are places that we're just not going to go. Now, the type of mask that we pick is going to depend on all of these factors and the environmental factors, our method of use. So there's a lot of little tiny details as you're making a plan that you're going to have to be aware of. Now, a single piece face shield and mask might look good on the surface, but do you wear glasses? Does your threat model require you to have your eyes contained where you can't touch them? Maybe a face shield is a better alternative, something that you can reach under, something you can clean under. Maybe you do need a full respirator, full enclosed mask. You need to make sure that it's fitted properly, that you're using it correctly. Now, one of the details that's become very important with our current mask situation is masks like these, okay? This is just a cotton homemade mask. It's basically a sneeze and a cough guard because this is not to protect me. The particles that come out of a human's mouth are very, very small. Now, if you do this experiment at home, you take a spray bottle, twist the nozzle as tight as you can as you're spraying, and get the finest mist possible. You'll notice that that mist hangs in the air a lot longer than the spray. Well, that's coming out of your mouth all the time. So if I wear this, it's going to block a bunch of that. It's not going to be perfect. It's not going to get everything, but it is going to slow that down. Now your N95 mask, your really good mask, it'll block a lot more of it if it's enclosed. If it has a relief valve in it, which will make it easier to breathe, and that's something you need to consider if you have breathing trouble. Breathing in a mask for long durations is very, very tiring. That vent is basically, it's going to act like a distribution unit for all of the vapor that comes out of your mouth. It's going to aerosolize it. It's going to make it spread a lot farther because when you just push air through a nozzle, that's what happens. You stir things up more. So if you're only worried about protecting other people and your mask has a big hole in it, you haven't solved your problem. But if that's not your concern and you need to wear a mask for a long time, then maybe you do need that valve. Now, thinking about some other little details, how warm or cold is it going to be outside when you're wearing your mask? Do you have a beard? Do you have long hair? Do you wear glasses? Do you wear contacts? All those things are going to be factors that you're going to have to play in mind as you build your threat model. So think about what's likely. Think about what you need. You may need more than one set of masks. You may need more than one type. And you also need to think reasonably about your quantities. Now, there's stories right now of people with 100,000 masks. Now, on the surface, that might seem excessive. But if you're treating that mask like it can only be worn for 4 hours out of a day, all of a sudden you can see how one person could go through a lot of masks, 8-hour shift, 2 masks a day, potential contamination of the mask, so you want spares. One person can burn through 10 masks in a day. What happens if a package gets damaged? What happens if a mouse gets into a package and eats half of them? Suddenly you can see why people bulk buying starts to not be quite so strange. Now, I don't think you need 100,000 masks. And there's good information right now from the CDC and WHO on preserving and sterilizing N95 masks. But you need to be considering, how long am I going to need this mask for? The last set of fires we had, there were people wearing masks for a few weeks, depending on where they were. Now, if you're going to wear a mask indoors 24/7, I wouldn't recommend wearing them at night because, again, that whole CO2 problem. But what you want to make sure that you're doing is, plan for the potentials of what you're going to need. Make sure that you have the right stuff. Don't be panic buying. This is what I've got because I'm not buying any masks right now. Other people need them. We'll solve that problem later on. Anyways, that's just a start. See you next time on Comm Survival.